Okay, so hello everyone, and in today's lecture, we'll try and wind up our lecture series on like basics of network theory. And from tomorrow on, we'll try and start with Telegon's theorem, or probably Thevenin theorem, whatever suits. For now, today we'll take a few more questions. All the rest over topics like questions based on capacitances, questions of different dielectric mediums, questions on different kind of cube kind of structures in resistance calculations and equivalent resistance calculations. We'll take one question every day so that we get closer to the point from where the more questions come in competitive examinations. Okay, so tomorrow on we'll start our lecture series on theorems in network theory. Okay, so this is the first question for today. Today I tried and brought a lot of questions based on I yesterday also I discussed. I'll bring more questions based on resistances in infinite series. So those and also a few one or two questions of different kinds also. I'll try and bring questions which engage your mind and which improve your understanding of the topic. Okay. So in this lecture for today, the first question is in the network shown below, if the power consumed in the network shown below, if the power consumed by 6 ohm resistor is 0, find the value of V. Okay, so this is 1. Okay, do pardon my figures and diagrams because I wanted to save time, so I've just used rough drawing here. Okay, so the question asks you to find the value of V in this network, right? Right, and what is given to you? We are given that the power consumed by this 6 ohm resistor is what? It is 0, right? So if this is 0, what can you deduce from this? Okay, think about it. Think about it for a minute and then tell me. Okay, so if if you're given that the power consumed in this 6 ohm resistor is what? It is 0. Can I say? Can I say power consumed by a resistor is given by what? What is the power consumed in a resistor? Can I say it is I square R, right? So, so it is given to you, it is given to you that this value, I square R is equal to what? 0 if for 6 ohm. Okay, 6 ohm I am writing it here. So it is given to you by the definition in the question, it is given to you as 0. So can I safely deduce from here that I in this case would be what? 0. Can I say it? Right? Now, now tell me how can a network which is connected, it is not an open circuit, it is a closed circuit, but there is no current flowing in this branch. Can I say it? Because there is no current flowing in the 6 ohm branch, we have reduced from the fact that we were given, right? So if there is no current flowing in this branch, what can you say about it? What could possibly be the reason? See, it is not an open circuit, and it definitely by we can say definitely without doubt we can say that the current in this branch is zero, because that is what is given to you in the question. The power consumed is in the 6 ohm resistor is zero, so we deduce that the current is zero. So when uh, in other case, when otherwise can the current be zero? Let me label this as V1. Let me label this as V2. Now tell me if whatever I am suggesting is true or not. Tell me, if V1 is equal to V2, only then only then I would be 0, because it is not an open circuit, so there is no other possibility. Only when 2 points are at the same potential, there will be no current flowing in the branch. So can I say V1 is equals to V2 if I is equals to 0, right? If I is equals to 0, then V1 is equals to V2. Can I say it? Can I say that? Right? Now, look closely and tell me, this is one network, and if okay, let's not talk about loops here. Let me just tell me, if there is a current, say some current, let me call it, say, let's just name it for the sake of naming I dash. Okay, if I dash is flowing from this direction and there is no current in this branch, where will the I dash go? There are two branches here. There is no current flowing in this branch, so all the I dash will divert in this direction, right? So this is the only way of the current to flow for this source, right? Similarly, in this loop, let me call a current called I double dash. There is no current in this branch. Where will this current go? In this branch, I double dash, right? So I double dash flows from here to here. I dash flows from here to here. They are what? They are kind of working as independent networks, right? So tell me, if the entire current flows in this direction, in this way, by voltage division principle, can I calculate the potential here? Can I calculate the potential V1 here? Can I do it? What will be V1? Let us ground this point. What will be V1? The potential across this inductor J1 ohm is whatever the potential builds up across this J1 ohm. That would be your potential V1 here. Can I safely say that? Tell me, is it safe to say that the current will only flow in this loop, and the potential V1 can be completely determined by the potential drop across this inductor? Okay. So, can I write by voltage division? The voltage divides in the same ratio as the impedances. So can I write V1 is equals to what? J1 ohm divided by, what is the resistance? 1 plus J1. Again, I'm avoiding writing ohm in, like, let me write ohm in general, so that it does not look a lot, it does not look very clumsy. Okay. Okay. And what is the potential across it? So this is what? It is the voltage division, right? And what is the potential which is dividing it is 20 angle 0 degrees given to you, right? So this will give you what? Your V1. This will give us what? Our V1. I am rewriting it for you, and I hope you're uh, clear with converting rectangular forms to uh, radians. I hope that I don't have to teach you. Tell me, can I write this as 20 angle 90 degrees? What is J1? Can I write it as 1 angle 90 degrees? Right? So what will our equivalent be? And this would become root over 1 plus 1 and tan inverse of 1 by 1. Angle would be tan inverse of 1 by 1. That would be tan inverse 1. What is tan inverse 1? Angle 45 degrees. Can I write that? I am not solving it here because it will become very clumsy. But can I write this as root 2 angle 45 degrees? I hope you are clear. I hope I don't have to explain you this. Simple mathematics that we have done in our 10th, probably even 12th standards. Conversion of polar coordinates to, conversion of rectangular coordinates to polar coordinates. Can I write this as 10 root over 2 angle 45 degrees? So this will be what? This will be your V1. Okay, okay. But V1 is equals to V2. This we have derived here, right? So, and okay, now what would be V2? V2. This I double dash flowing, there is I double dash flowing, and this is 5 ohms, this is 5 ohms. Can I say V2 is equals to, V2 is equals to, again by voltage division principle, 5 upon 5 plus 5 times V, which we have to find out. This is our unknown value. So can I write this to be V by 2? V2 is equals to what? V by 2, right? So V1 is equals to 10 root 2 angle 45 degrees. V1 is equals to 10 root 2 angle 45 degrees, and V2 is equals to what? V2 by 2. If I equate these two values, I will get my unknown. And what is my unknown? V. So V2, solving it in this book, okay? V2 is equals to V1, or or V by 2 is equals to 10 root 2 angle 45 degrees, or V is equals to 20 root 2 angle 45 degrees volt. This will be your answer. Okay. So in such questions, once you see, you probably might fear that how will we solve such questions. It is, utilize whatever is given to you in the question. Okay, whatever is given to you in the question, utilize that fact and go step by step, you will, get your answer. These are very easy questions. They shouldn't take a lot of effort. Okay. Okay. So, This is a new variety of question that I told that I'll be discussing tomorrow. That would be today. So tell me, how do you, I'm solving one question for you before hand. And then in the next two questions, you will tell me how to approach these questions. Okay? Okay? So in such questions, we see where exactly does our series repeat. So see, if you see, this series goes till infinite, right? So can I say this is, I'm breaking it here, okay? So this is what? Can I say, if this is Rin, this again would be Rin because it goes till infinite, right? So can I write it as R input here, this is 1, this is 1, and this is in parallel Rin, right? Can I do it? Can I write it like this? If you look from here, this is your R input, but if you look from this portal, like at these 2 points, again if you see, this is 1, this is 1, this is 1, this is 1, it extends to infinity, this is again what? R input. So is it safe to redraw this network like this? Is there any doubt? So can I write it as, tell me, can I write it as, if I have to solve this question, tell me, if I have to solve this, okay, I'm solving this here. Tell me, can I write it as R input? Tell me if I'm correct. R input is equals to 1 plus 1 parallel to R input, right? This is your equivalent. 1 is parallel to R input and this is your 1, right? So can I write it as R input minus 1? R input minus 1 is equal to R input into 1 upon 1 plus R input. Can I safely write that? Right? If you solve it, what it is into 1, okay? Please don't get confused. I know I have a very bad handwriting, but still. Okay. How would you solve this from here? Can I write it as R input square minus 1 is equal to R input. This would make our equation to be R input square minus R input minus 1 is equal to 0, or if you solve this quadratic. Okay, I am also not sure if in net physics examination you are allowed with virtual calculators. Are you allowed with virtual calculators in your net exams? In GATE we are, that I am pretty much sure about. In GATE we are given with virtual calculators, but in net exams, do you have access to your virtual calculators? Okay, in any case, try solving this quadratic and you will get this answer. Okay? Okay. Now, on similar lines, on similar lines, try solving this question. I have given you one example. I am asking you to solve this question which is on similar lines with what you were given before. Okay, tell me, can I draw this again like this? Okay, I am redrawing this network like this. Okay, so in such network, can you solve this question? See, it's easier if you remember, uh, you know, the value from this question, the answer of this question, because generally the trend that I've seen so far, I see a lot of people with a lot of questions with a similar pattern. So it is, desired that you remember this value. Also, please remember the pattern. It's not, you should know how to solve it, but in order to save time, it is easier that you learn this value. So, tell me, I am writing this value. Up till here, I am denoting it as R I N dash. Can I write R I N dash is equals to 10 times 1.618? Because in our previous question, what did we observe? We observed that each resistor was 1 ohm. In this question, I am saying, I am talking about RIN dash. Please be careful. Okay, in this question, I am talking about what? RIN dash. So it is 10 times what was given to you. So can I write it as RIN dash will come out to be 16.18 ohms? But was it your R input? No. R input was 10 plus RIN dash. Can I write that? So that becomes 10 plus 16.18, which will give your answer to be what? 26.18 ohms. Okay. Simple execution of whatever you have known so far, right? Simple execution of whatever you've known so far. We have just, in the previous question, we solved a question of similar pattern. I would advise that you remember such facts, but such questions, but it is desirable, it is not necessary. If once you know how to solve them, and if you're good at, solving quadratic equations and you are at ease with solving a lot of questions and you don't make silly mistakes there, then you can even avoid mugging them up, but it saves time. Once you know the concepts, it also gets easier to remember, but still the you should remember them for saving time in state PSC examinations, and also like other entrance examinations. In your PhD entrance examination, you'll find such questions, and it would save your time there. Okay, moving on, a question again of similar pattern, and before you attempt it, let me tell you, it wasn't broken down as 2 plus 2, it was 4 ohm here. But because I'm teaching you for the first time and this is the first time you're attempting questions of this sort, I have broken it down for you as 2 and 2. This is like I have made it easy for you to solve such question. But you need to be alert enough, you need to be aware enough to use the information given to you to the best of your benefit. Okay. Okay, now tell me, how are you going to approach this question? Okay, what is the pattern that you see? The first thing that we observe is whatever is on the left hand side is also on the right hand side. Is that clear? Is that clear? Can I say that? Give me a second. Uh, okay, okay, okay. I'm continuing from here. Let me write this as point A. I'm writing this as point B. This is your point A. This is your point B, right? This is Rx and this is Rx. Before I tell you anything, please listen that this becomes your, I am denoting this value as Rx. What am I doing? I am denoting the left hand side value as Rx. Now, I have also told you that this resistance and this resistance are what? Are what? They are similar in nature. So is it, tell me, is it justified if I denote this as equivalent to this? Can I say that? Now, what is it asking us? It is asking us R equivalent. So can I write R equivalent is equals to Rx by 2, right? Can I say that? Can I say that? Right? Now, 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 I am just taking, in this case, I am just taking what? I am just taking Rx. I am just taking what? Rx. So, Rx is equals to what? Tell me, is it correct? Is there any doubt up to this point? Is there any doubt up to this point? Is there any doubt up to this point? Now, again, look closely and tell me if it is correct. I am just asking you to observe this point. This resistance. I am naming it as Rx dash. Tell me, is it safe? Let me draw it and then I'll tell you. Okay, I am saying Rx dash is equals to 2 times Rx. Is it safe to deduce that? Would it be wrong if I say it? Tell me. See, what was given to you? It was given to you as 2 and 2 here. Now what is Rx dash? 2 square and 2 square. Everything that you were given with, it is what? It is multiplied by 2. Right? Every resistance value is multiplied by 2. Right? So can I write, tell me, can I write this as by observation? Can I write, I am redrawing the network for you, okay? Rx is equals to 2, 2, and what is the thing that is repeating? 2 Rx. Can I say that? This is equal to what? Rx dash. I took Rx dash here and then I told you why it is equal to 2 Rx. So is it safe to write like this? Right? Right? Now tell me, how are you going to, like, can I say, can I say, R, can I say Rx is equals to 2 plus 2 parallel to 2 Rx? Can I say that? Look here, 2 Rx is parallel to 2 and this is in series with 2 ohm resistor. That is what I have written here, right? Or can I say Rx minus 2 is equal to what? Is equal to 4 Rx, okay, upon 2 plus 2 Rx. There is the equivalent resistance of 2 parallel resistance. That is how we calculate, right? Solving this, tell me, can I write it as 2 Rx plus 2 into Rx minus 2 is equals to 4 Rx, right? Can I say, can I say 2 Rx square minus 2 Rx minus 4? Correct me at any point if you find that I might have made any mistake, okay? Please feel free to interact. Okay, so your final equation becomes Rx square minus 3Rx minus 2 is equal to 0. Solve this quadratic, find Rx, and what will your R equivalent become? What did we find out our R equivalent to be? R equivalent was Rx by 2. So whatever Rx you calculate, your R equivalent would be what? Rx by 2. Find out the Rx from this quadratic equation. Okay, let me do it here itself. Rx minus 2Rx. No, that won't give you a solution here. See, whatever is the answer. The point is, this is how you're supposed to. This is how you're supposed to, approach such questions. Okay. Okay. So I'm leaving up to I'm leaving this at this point. Find an answer for yourself. Please check if I've made any mistake. Although I've tried not to. But the point is you need to understand how to solve such questions. Okay. Okay, look for any patterns that you can see, look for how you can reduce it into eventually into in terms of our input itself, and that is how you solve such questions. Okay, easy approaches, but you need to be open to ideas. Okay. Okay, this would be our last question for today. And from tomorrow on, I'm planning to start theorems, because I've seen a lot of requests regarding theorems, and that is what you fear more. So tomorrow on, I'll start taking lectures on theorems, but I'll also take a small section of questions based on basics also, and not basics, rather they'll be miscellaneous topics. Okay, so so that you can parallelly cover course from the other end. Okay, and give me a week or two's time, and after a week or two we'll start with op amp and analog electronics also. Okay, I'll need a week's time now. Okay, this is the last question for today. With respect to terminals A and B, this is your A and B. With respect to terminals A and B, the network shown in the figure acts as a load resistor. Okay, find the load resistance offered by the network. Tell me. You are, see what you are provided with in this question. You are provided with a dependent source. You have to find what? The equivalent resistance offered by this network, and this itself is what? This itself is your load. Tell me, how are you going to solve it? In such questions where you are provided with where a network in itself becomes a load resistance, and you have no other way of resolving the network. How do we approach generally? We approach it by applying a fictitious battery of 1 volt. A fictitious battery of 1 volt. Okay. So the potential would be 1 and the current is inward. See, this I1 is there's a current dependent voltage source here, right? Now, now tell me, how are you going to approach? Okay, I am applying KCL or nodal analysis. You are free to use your own method. You can use your KCL in case it suits you. You can use nodal analysis if it suits you. I am using what? I am using nodal analysis in this case. Okay. Tell me. I am assuming what? All outgoing currents, right? So can I write at this node? Let me call this node as C. At node C. At node C. Can I write minus I1 plus, let's call it plus 1 volt divided by the, what is the potential here? 1 volt already given to you, divided by what is the resistance? 2 plus outgoing current we are assuming 1 minus 4I1, right? The potential here is 4I1 divided by 4 is equals to 0. Can I say that? Right? I am multiplying the entire equation by 4. This will leave me with 4I1 plus 2 plus 1 minus 4I1 again is equal to 0. Can I say I have minus 8I1 is equals to minus 3, or I1 is equals to 3 by 8 amperes. Okay, so this was the last question for today. In questions where the network itself is given as a resistance and there is no other way to find out, what do? We apply a fictitious battery of 1 volt, or otherwise what could be the approach? We could apply a fictitious current source of 1 amperes. Okay, but we are to identify what? Resistance. And so the simple V by I ratio would give you your resistance, right? Now I1 I have calculated, but still we have not calculated our R. So R input through this network from here would become V upon I. What was V? V is 1 volt. What is I? 3 by 8. It becomes 8 by 3 ohms. That is your answer. Okay. So revise whatever I've taught you today, and for tomorrow I'll tell you in advance what theorem we will be taking. Kindly join the classes from tomorrow, because so far I could probably understand that these are lectures on basics, so probably you would all have been you are all well versed with such topics. From tomorrow on we'll be starting your course. So please don't miss your lectures from tomorrow on. Okay? See you tomorrow.